All right, everybody, give a round of applause for Salvador Mendoza about Samsung Pay tokenized numbers, flaws, and issues.
Thank you. It's a pleasure to be in DEF CON this year. And I'm going to talk about Samsung Pay tokenized numbers, flaws, and issues. Also, we're going to talk about crocodiles and laser beams today. Basically, I have 20 minutes to explain almost 1 year of my research. And we are going to start with the agenda for today. We're going to talk about terminology, analyzing tokenized numbers, MST and NFC protocols, token phases or status, of course, flaws and issues. The user scenarios, I'm going to introduce 2 tools for today. At the end, I'm going to talk about international tokens. For terminology, I'm going to use NFC for near-field communication, MST for magnetic security transmission protocol, BTS for Visa Token Service, which mainly are the protocol for the tokenization process. Tokenized numbers, where it's a process where the primary account PAN number is replaced with surrogate value. In this case, it's going to be a token. And the token is a voucher to interchange for goods or services. TSP for token service provider, who's in charge for the tokenization process. And PAN for primary account number. So let's start analyzing tokenized numbers. Basically, when you're going to make a payment, Samsung Pay is going to create 3 tracks. It's like when you swipe your card. But this time, all the tracks are the same values. Why? Basically, because it doesn't matter which track the terminal is going to detect. If it detects anyone, the transaction can go through. If we analyze the last 20 digits of the token, we need to analyze like they are different counters. Basically, the first 4 digits are for its new expiration date for the new virtual credit card. The last 3 digits are for new service code. The service code is very important because, for example, you have a PIN and CHIN protection card and you add it to Samsung Pay. Samsung Pay is going to replace this value so you don't have the necessity to have a physical card with you to make a payment. The last counter is a transaction range, which plays at the CVV role. The next counter is a transaction ID, which mainly increases +1 every time you use Samsung Pay. And the last 3 digits are random numbers to fill the American Banking Association format, or track through in this case. Offline and online mode. Basically, when you are on offline mode, the counter in the middle of the token doesn't change. But when Samsung Pay connects to the internet, this counter increases every like 3 or 4 transactions. One of the problems with Samsung Pay is that you can make payments in airplane mode. This means that Samsung Pay doesn't have a full control of the tokens. Let's talk a little bit about the token phases or status. Like any other transactions, Samsung Pay has different, the tokens of Samsung Pay has different status, like for active, pending, dispose, enroll, expire after a period of time, and suspended. This is how, according to Visa Developer Center, how a tokenization process or provider update the tokens. It needs a B provision token ID and also a IP key in a Johnson format. Please keep in mind this is slide that we're going to use in the next example. So the file structure is very important. I found more than 20 databases in the calls of Samsung Pay. Some of them are for connections, for certificates, encryption, directories and files. I'm going to take a look at the structure on the bottom of the database, CBP, Jan, Encrypt database, to see the structure of this database. If we see the structure of this database, we can find some of the fields that we need to update a token. This means if an attacker could find a way to decrypt or to get these provision token IDs, he will be able to update a token all the time, even, for example, it's expired or disposal. Maybe you're thinking, these databases are very encrypted. But what I found was that encryption from databases using static passwords. Basically, we see this method, the encrypt method, but it's not yet the database manager. Also another methods call this function to encrypt the data. Continue with flaws and issues. When I was able to make a backup of the Samsung Pay databases, in the card table, I found the token expiration date wasn't blank, specifically in that field. Also, the IB retries party time implements timestamp format, which expire over 24 hours. So basically, the main problem here is if Samsung Pay generates a token, but you don't use this token to make a purchase, that token is still alive or active. For example, if I ask you, can you show me how Samsung Pay works? And you show me, but you're not making a transaction, actually, but that token is still alive. When you close this application and open again, you're going to get a new token, but the last token is still alive. Continue with flaws and issues. Basically, you are suspicious that somebody captured your token and delete your virtual credit card, and you add it again. The last digits of the new virtual credit card, they're going to change just in the last 4 digits, basically. I make a log, adding and deleting the card. So, let's go to the interesting part. Dangerous scenarios. We're going to talk about reversing the encrypt and decrypt function, social engineering, jamming MST signals, and guessing the next token. When an attacker is able to decrypt, to reverse these functions, he will be able to get, I think, almost the information for all the encryption function because they use for many methods. Let's talk about social method. Basically, I made a tool using Raspberry Zero, LiPo, Power Boost, a credit card reader, basically around $50. I want to show you an example how it works. So, like the example that I told you, you have this tool on where in my hand. I can capture the tokens when I ask you how Samsung Pay works. And this tool sends these tokens by email. So I can use that token using another tool, like Mag Spoof tool from Sammy Camcar. Thank you, Sammy. So basically, when I got the token, I compile, and I go to the grocery machine, and I try to use that token. So I select the product, and it's authorizing, and it's vending. Thank you. Now let's talk about JamPay. JamPay is a jammer. It runs 3 services. One is for jammer, to jam the terminal, another is for the email service, and the another is for you can see the tokens in the web browser. Basically, it's running a Python web server. So an example, let's imagine that you're in Vegas, right? So we're in Vegas. So basically, I found a machine, and I use my jammer. So the main point here, the jammer is all sending magnetic MST signals, magnetic secure transmission signals. When a user comes to make a transaction, the terminal is not anymore in input mode. So the jammer is going to detect the MST signal, and they're going to send it to me by email. I got the token. So after that, I use a Mag Spoof. Again, Sammy, you're my hero. And I make a transaction. After that, I'm going to select the drink. I'm vending. So basically, that's the example I have. I was thinking about to get a token, but basically I forgot my crowd reader. Sorry about that. So let's talk about international Samsung Pay tokens. I assume that the virtual credit card was going to use the same restrictions like a physical card. Like for example, when you're going to another country, you basically call your bank and tell them, hey, I'm going to be in, let's say, Mexico. So the bank take care of it, and you can use that card in that country. What I found interesting was I sent one of my tokens to Mexico to see some of my friends can make a purchase and how kind of restrictions the bank is going to have. So basically, it was July 8th. I sent one of my tokens to one guy in Mexico. And he's trying to charge me 20 Mexican pesos, basically. So the transaction went through. He asked for his signature. That's not my signature, but who cares? So the transaction went through, and I got the confirmation from Samsung Pay. You had spent 20 Mexican pesos, even when Samsung Pay is not in Mexico yet. So the takeaways for today: Samsung Pay has some levels of security, but it's a fact that could be targeted for malicious attacks. Samsung Pay has some limitations in the tokenization process, which could affect customer security. And finally, token generated by Samsung Pay could be used in another hardware. Please, if you have any questions, this is your time to ask me. I need to say thank you to all these guys. Really appreciate your help.